Here we have this series whose rth term is given. What is the rth term? It is r by r power 4 plus r square plus 1. Then we have to calculate limit n tends to infinity, the sum of all these terms like t1, t2, t3, t4, whatever, up to infinity. Okay, so let us try to take this term and break this term, the nth term or rth term, and try to see if we can fit this into a telescoping series where we can show this as um, difference of two consecutive terms. Right, let us try to make this into that. Okay, r by r power 4 plus r square plus 1. There is an r power 4, there is an r square. So let us try to create a perfect square here and see whether if we can show this as difference of two terms, probably tr and tr minus 1 or tr and tr plus 1. Okay, let us take this r by r power 4 plus r square plus 1. This r power 4 is r square whole square plus r square, we can write it as 2r square minus r square plus 1. What does that mean? This one, and this one. These three together will make it as r square plus 1 whole square. Right, a square plus b square plus 2ab minus r square. We are talking about the denominator. Okay, and what does this mean? This means r square plus r plus 1 or r into r square minus r plus 1. Right, a plus b into a minus b. R square plus r or r square minus r plus 1. R square plus 1 minus r square plus 1 minus r. All of this, the numerator will still remain as r. Okay, now here we can still split, right? So for example, r square plus r plus 1, this minus this is equal to 2r. Right, r square will get cancelled, r minus of minus r is 2r, 1 minus 1 will get cancelled. So we can write this thing as half of 1 by r square minus r plus 1 minus half of 1 by r square plus r plus 1. Okay, why we are doing this? Because this part minus this part. Okay, what will that become? R square plus r plus 1 minus of r square minus r plus 1. Right, by this product r square plus r plus 1, r square minus r plus 1. Right, half of this. This thing will be equal to this one will get cancelled. This will be left with 2r. This 2 and this 2 will get cancelled. This is equal to this one. Right, this is equal to this one. So that's why we are writing it like this. Half of the difference of this. Now again, if you see, what is this? This is r into r minus 1. This is r into r plus 1. Okay, so we have 1 by r into r minus 1 plus 1 minus of 1 by r into r plus 1 plus 1. Now we have got something familiar here, or we got something nice here. Let's say if we take f of r is equal to 1 by r into r minus 1 plus 1. What will be f of r plus 1? F of r plus 1 would be, in place of r, we will put r plus 1, and this one will become r plus 1 minus 1, which is again r plus 1. So basically, if we call this as f of r, this will become f of r plus 1. Okay, what does that mean? We have created this tr. Tr is equal to our original term, where we started, is equal to half of f of r minus f of r plus 1. Right, which is our original tr. This tr, we have broken this into half of f of r minus f of r plus 1. What does that mean? T1 is equal to half of f of 1 minus f of 2. Right. Similarly, T2 would be half of f of 2 minus f of 3. Right. This is T2. Similarly, what is our Tn? What is our Tn? Tn is half of f of n minus half of f of n plus 1. This is our Tn. Now, what is the sum that we want? The sigma is T1 plus T2 plus T3, T1 plus T2 plus t3 plus up to tn, where n tends to infinity. This is what we are looking for. Now, if we do this sum, right, the second term and the first term of all terms will get cancelled. Second term of t1 and first term of t2, second term of t2 and first term of t3. Likewise, everything will get cancelled except the very first one and very last one. What is our very first one? Half of f of 1 minus half of minus again half of f of n plus 1. Only these two terms will be left. Everything else will be cancelled. What is our f of 1? F of r is 1 by r into r minus 1 plus 1. Right. Now, what is our f of 1? 1 by 1 into 1 minus 1 plus 1. So, f of 1 is actually equal to 1. And what is our f of n plus 1? F of n plus 1 is it will be in place of r, we'll put n plus 1. 1 by n plus 1 into n plus 1 minus 1, which is equal to n plus 1. Right. So, this entire summation t1, t2, t3 up to 2n, tn is actually equal to half of 1 minus 1 by n into n plus 1 plus 1. Now, what will happen when n tends to infinity? Obviously, this part will tend to infinity. So, this entire part will become 0. We'll be left with half of 1 minus 0, which is equal to half. Right, guys? So, ultimately, this limit is actually equal to half. Right. So, what we have done, we have taken this term, the generalized term, and we try to make it as a difference of two consecutive terms. How did we do this? First, we had completed the square. Right, we have completed the square and made it look like r square plus 1 whole square minus r square. And then this one, r by this thing, we had shown it as difference of these two items. Half of difference of these two items. Right, one is a plus b, another is a minus b. Half of difference of these two items, we had shown it. Now, this one, we have realized one of them, the second one, is actually related to the first one. Right, if we call one of them as f of r, the second one is actually f of r plus 1. So, that is what we wanted. Every term is actually half of f of r plus f of r minus f of r plus 1. Basically, half of difference of two consecutive items. Right, what does that mean? When you sum all of this till infinity, then except the first one and last one, very last one, everything else will get cancelled because it is always the sum of or difference of two consecutive terms. Right, every second term and every first term of two adjacent terms, adjacent items will get cancelled. So we'll be left with only the very first one and very last one. The very first one is actually 1 because 1 by 1 minus 1 plus 1, this becomes, this part is 0. Very first term is actually 1 and very last term is 1 by n into n plus 1 plus 1. Now, we want this n to tend to infinity. Obviously, this part will become 0. We'll be left with only half. Right, guys? Hope you like this. Thank you.